HC Piper Manufacturing welcomes you to this animated look at our typical VRU, or Vapor Recovery Unit. In a SAGD or steam-assisted gravity drainage oil production plant, heavy oil is produced from the ground using steam to lower the viscosity and allow the oil to be pumped into the plant and from there to the storage tanks. The storage tanks receive and distribute the oil. Consequently, the level of oil in the tanks is subject to many fluctuations. The void between the oil level and the fixed roof is filled with a natural gas blanket to prevent oxygen coming into the system. As the oil will be hot and contain small quantities of water, light hydrocarbons, and asphaltenes, these products will vaporize into the natural gas, resulting in difficult mixture. As the level of liquid in the tank rises, the vapor in the void is compressed and must be removed to avoid overpressurizing the storage tanks. Because this vapor is at a very low pressure, just a few ounces above atmospheric pressure, it must be compressed in the VRU to increase its pressure before it can be processed in the plant. In addition to being environmentally friendly, the VRU allows for the conservation of natural gas and has the ability to recapture light hydrocarbons in liquid form. The changing conditions and variable nature of the vapor make it very difficult to handle reliably with most types of compressors. Reciprocating machines will have problems with liquids condensing in the suction line and potentially entering the compressor, or vapor condensing in the compression cycle. Screw and vane machines will have problems with condensed hydrocarbons, reducing the lubricity between the wearing surfaces, and the presence of asphaltenes may cause fouling up of the compressors. Add to this the possible presence of H2S and CO2, and the vapor can be corrosive and potentially deadly. Reliability is obviously a key concern, as the alternative to the VRU is to release this vapor to the atmosphere either directly or by flaring. The liquid ring compressor is the most reliable way to handle this vapor. A liquid ring compressor has no touching parts between the rotor and the casing, and is able to accept some condensed liquids without damage to the machine. The three purposes of the liquid ring are to cool, lubricate, and seal. The liquid ring compressor is the main compressor type used in HC Piper's SAGD VRU. HC Piper's VRU may be supplied complete with its own building or for installation in a client's building. The module is designed to meet the specific customer requirements and plant specifications, and can be provided with a raised platform giving access to relief valves. The VRU is designed to allow maximum operator space around the equipment for maintenance and service. A crane is also provided in the building, and care is taken to ensure major items can be removed through the main roller door. Within the building, the vapor from the tanks is drawn into the vapor recovery module and passes through the shell and tube inlet heat exchangers, where it is cooled to a suitable operating level. The cooled vapor, together with any condensed liquids, then flows into the liquid ring compressors. The compressors, which may be single or two-stage machines depending on the operating requirements, raise the pressure of the vapor to the desired discharge pressure. The compressors typically run at a fixed speed and fixed capacity. As more or less capacity from the unit is required, compressors can be started or stopped. A key component of HC Piper's proprietary design is the ability to start and stop compressors without operator intervention. Further capacity control is provided by a bypass line within the system. HC Piper's Vapor Recovery Unit can operate indefinitely at any capacity from 0 to 100%. Together with condensed liquids and some ring fluid, the vapor leaves the compressors and enters the discharge separator. Here the vapor separates from the liquids and exits the discharge separator, off the VRU and into the plant. In the discharge separator, the liquid is further separated into water and hydrocarbons. The hydrocarbons can be taken from the separator at this pressure. More commonly, it is pumped through a low NPSH, low-flow, high-head pump, and used at a higher pressure in the plant process. Any excess water produced by the cooling and compression of the vapor can be drawn off the vessel at vapor discharge pressure. In a full recirculation system, water is taken from the discharge separator and cooled in plate and frame heat exchangers to be returned as ring liquid into the compressor.